Solar's Chapter 5, Safety of Navigation, states that compass errors should be determined after every large alteration of course, and at least once every watch when there have been no major course alterations. On coastal passages there are usually sufficient position lines available from coastal features and aids to navigation to make sights unnecessary. Navigation guidelines recommend checking the compass at least once per navigation watch and after every major alteration of course. Commercial vessels have a compass error book, where all compass errors done are recorded. The navigator records that a compass error has been done or the reason it has not been done in the logbook. Celestial bodies present options for checking the compass. Even if there is partial cloud cover, a sharp-eyed, well-practiced navigator will get the compass error done. The amplitude of a celestial body is the angle between the true east point of the compass and the object when rising, or between the true west point of the compass and the object when setting. Amplitudes of the sun can only be observed when the sun is rising or setting. The Earth's atmosphere consists of layers of air of different densities called ionosphere, troposphere, D-layer, E-layer, etc. The varying air densities causes the light from a celestial body to be refracted or bent. The effect of this refraction is that the height of any celestial body, including the sun, appears to the observer to be greater than it actually is. When celestial bodies are rising and setting, the light from them passes more obliquely through the atmosphere than at any other time. Refraction is quantified as 33 when the body is near the horizon and 0 when it is directly overhead. Amplitude can be computed using the formula amplitude equals sine minus 1 sine declination / cosine latitude. The azimuth of a celestial body is the angle at the observer's zenith between the observer's meridian and a vertical circle through the body's center. Azimuth can be found by using the ABC tables, or by using a scientific calculator with trigonometry functions. Whether the ABC tables or the calculator is used for the computation, the method of the observation is the same. We observe the bearing of the celestial body, and note the time and the deduced reckoning position. Then the observed time is converted GMT, to enter the Nautical almanac. The GHO and the declination of the body, for the day and time are extracted from the Nautical almanac. The longitude is applied to the corrected Greenwich hour angle to obtain the local hour angle. The information required for the calculator or the nautical tables are the same. From the observation, we use the DI latitude, and from the Nautical almanac, we use the LHO and declination. When a star has been positively identified, a bearing can be taken of the star, and the time and D are noted. The local time needs to be corrected for longitude, and the GMT for the bearing obtained. The GHO varies, and the increments are found from the Nautical almanac. We apply the SHO of the star to the GHO varies, to find the GHO of the star. Then we apply the DR longitude to the GHO of the star to find its local hour angle. The formula for finding azimuth is shown here. It looks daunting, but it is not that bad. We need 5 inputs to use the formula. We should find these, separately, with the calculator and note them down. Find, both, the sine and cosine of the latitude. Find the sine and cosine of the local hour angle. And find the tangent of the declination. The formula tells us to multiply tangent declination by cosine latitude, and note the product. Then multiply cosine LH by sine latitude, and note the product. Next, subtract the second product from the first, and find the inverse tangent of the difference. The resulting angle is the azimuth. To use an amplitude for determining compass error, we have to find the time of sunrise or sunset on the day. If the date is not the middle date on the Nautical almanac, then we must use the tri-daily correction for the previous or following page, and interpolate. Next, we find the GMT of sunrise on the day. The GMT of sunrise is used to find the declination of the sun. The amplitude formula is sine amplitude equals sine declination divided by cosine latitude. We need only declination and latitude for the amplitude calculation,